Okay, good morning. So today we're going to kind of finish the ER exercise, and then if we have time, we're going to switch to the SQL programming. And also, I want you to be aware of that on next Thursday, we are going to have the term exam. I think the only term exam in this class. So this class we don't have final, but we do have a term exam. So for all of you who enrolled in HDO1, I think you're required to come to the classroom for the exam. And also we have online students. So for the online students, please send me your remote proctoring service contact so that I am able to send the text paper to your remote proctoring services. Okay, so I think my plan that this Thursday you're going to have the second assignment due. So please finish all your assignments by then. And then next Tuesday we will have a brief review class to discuss what we learned so far. And I'm only going to cover the key subjects that we covered in this semester so far. And so that hopefully it can prepare you for the term exam. But anyway, the term exam will cover the relational data model, so including the relational data model constraints, the concept about the key and super key, and the concept about the key and the foreign key, means foreign key and the reference key. And then we also talking about the kind of constraints violation. And then we also discuss about the closure of a set of attributes. And so whenever we calculate the closure, usually we only focus on the attributes for a given relation schema. And then given a set of attributes along with a set of functional dependencies, then how we can derive the closure of that set of attributes. Excuse me. And then the normal forms and the normalization process. So that is very important. And then for the ER design, we pretty much only focus on that, given a database description, how we can design an ER diagram. So that's the key subjects we're going to cover in the term exam. So the next Tuesday, we're going to have a review class, and maybe short review class, and then next Thursday, we're going to have the term exam, okay? So any questions? If you don't have any questions, then we move on to the wrapping up the ER design for the university database. I think in the last class, we kind of discussed that how we model the entity types. So in our initial model, we may have a query report as a separate entity type. Then when we examine the relationship among those entity types, so for example, in this example, we can either infer from the data description, or we can simply identify the attributes and the entity types that refer to the same real-world concept. Then we can refine those attributes into relation type. Okay, so I think that's pretty much what we got here. So we refine major and a minor attribute of student into major A and a minor A relationship between student and department, because major minor, these two attributes actually have the same semantic as the department, because they are referring to the majoring department and the minoring department. And the controlling, and for the course, the offering department and the department entity type, they also refer to the same thing. So that's why we refine the offering department of course into a relationship type between department and the course. Okay. And then between the section and the course, there is a course attribute in the section anti-tab in the beginning, then we can also refine this course into a relationship between the section where the course attribute belongs to and the course anti-tab. Okay. And you may notice that after we remove the course, we only have the instructor, semester, section number, and the year. So all of them together still not be able to help us to uniquely identify a section. Why? Because given specific semester, a specific year, and given a specific instructor, that instructor may teach multiple classes. For example, like me, I'm teaching 3 classes this semester. So I have 01, for example, or actually 01 session number for all the classes I'm teaching. So that given my information, given the semester, this semester, given the year 2024, and given the section number H01, there's no way for us to distinguish 3 different classes I'm teaching because they all have the same section number, same year, same semester, and same instructor. So then at this moment, we realize that section is no longer a strong anti-tab, so a regular anti-tab, because it does not have a primary key. Okay, so that's why we refine the section into a weak anti-tab. Okay, then who is owner? So because we remove the course, so then we know that course actually is the owner of the section. Means that in order to get distinguish each section, we have to also add the course info in order to distinguish each section. Okay, so course in this case, course anti-tab is considered as the owner of the section, and the section becomes the weak anti-tab enclosed in a double rectangular box. And then the relationship between the weak anti-tab section and its owner anti-tab course will be called identifying relationship type. So we have to use double diamond box to representing the identifying relationship type. Okay. And later, when we examine the grid report, I think the one trick probably you have to remember the trick that if this grid report has like attributes that representing 2 different anti-tab, like student corresponding to student anti-tab and section, we have a section anti-tab. Then we can refine this anti-tab into a relationship tab between the student and the section. Okay. Then the letter grade and numerical grade will be the 2 attributes that belongs to that relationship tab. Okay. So then I think this semantics is very clear. So between the section and student, there is a text relationship actually capture what which section a student take. Okay. So if a student take multiple sections, then these 2 attributes, L grade and N grade, will be applied to each section. So in other words, if a student take multiple sections, then student will have multiple text relationship instance, and each relationship instance for an individual section that student takes, and that relationship instance will carry 2 attributes, L grade and N grade. So this case, it makes this design much kind of concise and also very easy to capture all the information we need for this database. So that's why we cross out the report, because we refine it into a relationship tab. However, this text does not have double diamond box. So that basically means that this is a normal relationship tab between an entity with a weak anti-tab in this case. I mean, even not, it does not necessary to be a weak anti-tab, but only the double diamond box only used to simply identifying the owner anti-tab of a weak anti-tab. So through this double diamond box, we can clearly see that, okay, the course is the owner of the section. That means that maybe section has to dependent on the course to exist in the database. Okay. Let me see. Okay, so now I think we are able to. So maybe come here. Okay, now we can examine the, for example, coordinate ratios. I mean, either coordinate ratios or participation constraints. Often I need a copy, please. Okay, so let me download the university database. I didn't have the. Okay. The reason I'm bringing this data description because when we specify the constraint, we have to fully follow the data description to see. Let me see. Yeah, I think you're able to view it clearly. So let's first using the coordinate ratios. So student major department, okay? So really depending on the university, I think generally a student can take double major. So let's see the data description, keep tracking students major department, minor department, if there's any. So although it says major department, then we can make assumption. So maybe this university allow the student to take multiple majors. So anyway, so if we assume that a student can major multiple department, then we're going to put okay. So we will put capital N on the department side. So that's N means multiple. So that indicates a student can major in multiple departments. Okay. Then we also need to put a number on the student side. So on student side, this number actually representing that given a department, how many students will major that department. Okay, so given a department, how many students will be major in the department. So then the number will be also multiple n. So that indicates given a department may have multiple students major in it. And then the n on the department side that given a student can major in multiple departments. Okay, so since we do not have the declared indication from the data description saying that a student can have multiple can major multiple department. That's why we're going to tap our kind of assumption. A student may major in multiple more than one department. Okay. So that's kind of the first one, assumption. So I think you're able to see it clearly, so let me make it smaller here, so we have more space. Okay, so the first one. Then for the minor, I think that's pretty much it's also saying the minor department, if any. So, but the yearly, I think a student can have maybe more than one minor, okay? This really depending on your assumption. If you assume, you can have different assumption. If you assume that a student can have only one minor, no more than one minor, that's fine, okay? So as long as your assumption and your design are consistent, okay? So then for the numbers here. So let's first see the student major. If I put N, that indicates a student can major multiple departments, okay? I think that's because it's not stated clearly in the data description, then that's why we also have to list it. Okay. Then the number, we also have to put number on the student side. So this number actually means that given a department, how many students can minor, so maximum number of students can minor in that department. I think apparently that should be multiple, so right? Because we only have N or 1 put on that side. So if we put 1, that indicates a department can have only 1 student minor in it. So that's really not very kind of reasonable. So that's why we don't want to put to N to describe the coordinate resource. So we're going to change it to M. Okay. Then let's go to the department offer courses. Okay, so each course has the kind of a course number and offering department. So it doesn't, in the data description, it doesn't kind of describe the information that we can use to infer the coordinate ratios. I think that's fine, so we can always make assumption. But anyway, in the standard setting, a department may offer multiple courses, right? So because usually academic department has some kind of degree program, so that's why we can put multiple on the course side. So this M basically indicates a department offer multiple courses. Then we also need to put a number on the department side. So this number actually specifies that given a course, how many departments can offer that course. If many, then we put N. If it's only 1, then we put 1. Okay, so there's only 2 possible values, 1 or N. 1 stands for only 1, and N stands for multiple. So then it's really depending. I think there's also no assumption here, no references, data description here. So I think then you can put whatever number you want, either 1 or N. So I think according to my understanding that according to the you are sometimes, of course, may be dual listed by multiple departments, okay? So that's why I put M here. So that indicates a course may be offered by more than 1 department. So, but you're okay to put 1 here, but that's also very reasonable. Means that a course usually maybe university requires that, although a course might be taught by faculty from different departments, but we only have 1 major department as offering department. So we only list 1 department as offering department. So that's also good. But here, since I put M, that means that a course may be offered by more than 1 department. Okay. So that's another assumption. And then for the section belongs to course. So since we have identifying relationship type, so usually identifying relationship type will be many to 1. So What is many? What is one? So basically, we're going to put the many on the section side. So that means that a course may have multiple sections. So maximum number of course, maximum number of sections a course can have will be multiple. However, each section can belong to only one course. So that's basically that's very clear. So we cannot have a section belongs to different courses. So that's why the one we will put one on the course side. Okay. So that indicates a section belongs to only one courses, or only one course. Okay, so that's kind of a one. Okay, any questions? Okay, so then student takes sections. So I think here it's kind of a student, usually a student given a semester, a student may take more than one class, but it's okay for one student only take one class. But the maximum number of classes a student can take should be multiple. So that's why we put, I think this kind of a more like the general university kind of policy. If you do not allow a student to take multiple classes within a semester, I think no one would like to attend that university. So that's why we put N on the section side. That's really describe that given a student, that student can take more than one section for a specific semester in the year. Okay. Then for the number on the student side, that describe that given a section, how many students can be in that section. Of course, usually we have more than one students in the section. So that's why we're going to put, sorry. I'm here, okay? So I think we pretty much finished the coordinate ratios. Then for the participation constraints. So participation constraints basically given, for example, given an entity, what's the minimum number of the relationship instance that entity can take? So in other words, whether that entity has to, whether each entity has to take participate in that relationship or not. If yes, that's the total. If no, that's the partial. Okay. So let's look at the student major. Okay. So student major department. So what do you think? Is total or partial? So I think it really depends. So I think usually a university will allow a student in the beginning does not declare the major, so the student can explore. I think usually this kind of student may have very strong interest in several kind of related to several majors, or in the beginning they have no idea. So if we assume that a student may not declare a major in the, at the time, then we can leave this line so as single. That means that students' participation is partial. So by partial means that some student does not participate in this major. So that means that those students do not have a major. Okay? So I can a student. But anyway, so I think in order at that moment, but in order for student to be graduated, then finally they have to declare a major. Okay. Then for the department. Okay, good question. So the question from for multiple values possible, you sometimes use n, other time use m. Can you explain when I should know to use which one? Okay, so actually this m and n can be interchangeable. So basically both representing the same thing, multiple. Okay, so if you usually you can put 2n, for example, student takes section, you can put n on the student side too. Okay, so instead of n and m, you just put n, that's fine. Okay, so That's basically, but I think usually people want to distinguish those M. But if you see all the N, sometimes you probably got lost. So that's why we put M, so to indicate the multiple. So anyway, both M and N, they representing the same thing, multiple. Okay, so then where to put N and where to put M, I think there's no rules. So as long as it is many to many relationship type, you have to put one as N and one as M. So regarding which side you put N and which side you put M, I think that's doesn't matter because both representing the same thing. Okay. Okay. So then regarding to the participation of the department. Okay. So it can be partial. That means that a department does not have any, because if a department participation is partial, that means that the department does not participate in the majoring. That for that department does not have any student majoring in it. Okay, so it's really depending on your assumption. So for example, I probably can assume that every department must have some student major in it. This might not be very, I think, always true. Okay, so but anyway, so the reason we type the assumption, then we can go to the users, so database users or owners. So they know more about the business rules, policies of this university, and then they can validate if some assumptions is kind of consistent with their policy, if some assumptions do not meet their policies. So, but then we can cross out some assumptions or revise some assumptions, and then we can revise the ER diagrams kind of accordingly. So, for example, I want to must have some students major in it. Okay, if this is my assumption, that means that a department, the participation is total. Okay, so then we have to draw the double line. Sorry, it's so hard to. Okay. So, okay, but you can also put the participation of the department for the majors as partial. So then you do not need to draw the double line, but you have to make assumption, clearly state that assumption. Okay, then for the minors. So how about student participation? I think in this case, a student participation should be partial. Why? Because not all students have a minor. So some students have minor, so they have to participate in this minor's relationship. Some do not, so they do not need to participate. So that's why we can leave this single line as is. That indicates students' participation in the minor's relationship is partial. And for the department, I think might be the same, in this case, might be the same, because a department may offer some minor programs, maybe some minor programs never be taken by the student. So it's, if you assume the department participation for minor is total, that's fine. And since I have assumption, so I think that's my kind of, or my belief, okay? A department minoring. So if a department does not have any student minoring in it, then the participation of the department for the minors will be the partial, okay? Then for the department of courses, so I think I show the courses participation is total. So that might be the kind of the common sense. Whenever a course is offered, it must be offered by some department. Okay, so at least it must be listed as offering by some department. So that's why the course participation is total. That means that every course will be participating this relationship, offers relationship, so that it relates to one department. Okay. Then regarding to the department, so the department participation, I don't think we can infer here. We didn't say that. It didn't say that every department must offer some classes. But I think, for example, in this example, I want to assume that a department must offer some courses. Okay, so if I assume a department must offer some courses, then we have to what? We have to put the double line on the department side. So it means that department's participation will be total. Indicate every department must participate in this offers relationship so that it can relate to at least one class or one course that offered by the department. But once again, you can make a different assumption. So if you assume that some department does not offer any classes, that's fine. Then you just keep the department participation as single, so you do not have double line. So double line usually means total participation. Then for this kind of identifying your relationship type in the double diamond box, that's basically usually always magnitude 1 relationship type, and also the participation of the section must be total. Okay, if the section participation is not total, then section will not connect into any course, because section is a weak anti-type. It cannot exist by itself. Okay, so every section must be associated with a course, even at ULR. So that's why the section's participation will be total. And the course, I think course participation should be also total in the sense that every course, no, maybe not. So depending on the situation. So if some courses is just listed in the catalog but never offered, then that course will not have a section, will not have any sections, because a course has section only when the course is offered in maybe listed in the class schedule. So when we have a catalog listing all the courses offered by each department, for example, I kind of proposed several courses when I first came here. I think we don't have the manpower kind of stress thing, so I won't have any availability to offer some courses I kind of proposed. So I know that some courses are listed in the course catalog but never be taught. Okay, so in this case, it's really depending on your assumption. So my assumption may be a course does not have a section. So that indicates a course may not be offered. Just more like a ghost course, just listed in the catalog but never be able to offer it. Okay, so then I put single line here. But if you have a different assumption, that's fine. So if you think a course must offer some, must have some sections, then it's okay. Then you just basically put the double line here. Okay. Then student takes section. So here I think we do have some. I cannot remove this one. Double check. So my so then depending on assumption, for example, today my assumption is different. So I think some sections may have students, some sections may not have students. So it is possible, but may not be always happening, but it's also possible. So then it's based on your assumption. So my assumption may be that some section may not have a student. Okay. So if that is true, if that's my assumption, then I put participation of the section as the partial. Okay. Then on the student side, so maybe we can assume that every student must take some section. Okay. So every student must take some classes or some courses. So those courses should have sections. So if that is true, then I will put the double line on the student side. So indicate the students, every student must take some section, okay, to maintain the student status. Good. Any questions? Okay, so I think we can probably use the same slide for a different one. Okay, that's fine. So we can put. So assume that we have same assumption. Okay, assume we make same assumption. Then we can also use minimal maximum. Okay, so minimal maximum and coordinate ratio participation constraint are the same thing. Because recall that coordinate ratio is usually representing the maximum number of relationship instance an entity can take. And the participation actually indicates the minimum number of the relationship instance an entity can take. If the minimum number is 1, that means that every entity has to participate. If the minimum number is 0, that means that some, for example, student major, some student has major, some does not, okay? Then this multiple, for the maximum number, we have coordinate ratios, we have only 2 values, 1 or multiple, okay? And participation constraints, or the minimum number of relationship instance an entity can take, can either take a 0 or 1, okay? So let's go here. So I think our assumption that a student may major in more than one, I think was, yeah, but a student may not have any major. So I think maybe it's easier for us to, so according to the, I have to reference back and forth. So our assumption that a student may not declare a major. So that means that the minimum number of the relationship instance for the student in this majors really sorry. Okay, so it should be 0. So 0 means that a student may not major in any department. And the maximum should be n. Usually we use small n to indicate that multiple. So it means that a student may participate in this major from 0 to n. So 0 means that a student does not participate in this major. And n means that it may participate in a major multiple times. That indicates it has multiple majors, okay? Then for the department, so we have a department must have some students major in it. That means that the minimum a department may have at least one student major in it, okay? So that's how so on this minimum maximum notation on the department side for the major will be 1 and n. 1 means that it have at least one student major in it because a department must have some student. My assumption that the department must have some student major in it, okay? Minimum should be 1 and maximum should be multiple. Then for the minor, so students If some student does not have minor, then the minimum will be 0, means that they don't participate in any relationship instance. If a student may have multiple minors, then the maximum will be small n, that means multiple, okay? Then for the department participation, so a department may not have any student minor in it. So that means that the department minimum relationship instance a department will participate in through these minors will be 0, means that some department does not participate the minors relationship at all, indicate they don't have any student minor in it. Then the n indicate a department may have multiple students minor in it, so that should be 0n, okay? Then the department of courses, okay? So I think for the department offering courses, so we require that a department must offer some courses. So the minimum should be 1, okay? Indicate it must offer at least 1 course. Then the maximum will be n, that indicate a department can offer multiple courses. Then for the course, the minimum maximum notation, that's a different story. So a course must have a department offering it. So this minimum will be 1, okay? However, a course can be offered by only one department. That indicates the maximum is also 1, okay? So the minimum 1 means that a course must be offered by one department. Then the maximum 1 means that a course can be offered by one and only one department. So that's 1, 1, okay? Then regarding to the belongs to, so a section is a weak anti-type. It actually must participate in this identifying relationship tab, the double diamond box belongs to, in order to relate to a course. So that's why the minimum will be 1, because a section cannot exist by itself without participating in any identifying relationship. So this identifying relationship will be belongs to, okay? So minimum will be 1. And the maximum, okay, a section can belong to only 1 course. So that's why the maximum will be also 1. Because if you put n, that has a different semantics. So if you put n at the maximum value, that indicates a section belongs to multiple courses. I think that's usually is not allowed in the university setting. So that's why we put 1 here at the maximum. So minimum is 1, maximum is 1. So it means that a course must belong to 1. A section must belong to 1 and only 1 course. Okay. So then we have another number on the course side. So I think we do have assumption that a course may not have any section. So if a course does not have any section, then a course will not participate in this relationship, belongs to relationship. So that's why the minimum should be 0. And then the maximum really indicates, given a course, how many sections belongs to the course. So the maximum number of sections should be multiple. Okay, so of course we have multiple sections. So like my course, like this course, I have FSC 7 case 2, 7320. So in this current class we have at least 2 sections. So that's why the maximum number of sections, of course, we have can be multiple. So we put small n at maximum. Okay. Then regarding to the student section, so we have some assumption. Every student must take some courses, some sections. So that's really indicates. Okay. So the students participation in this text relationship will be the minimum, will be the 1. So minimum only can take 2 possible values, 0 or 1. Maximum can take also only 2 possible values, 1 or n, small n, okay? So if we put the 1 and n on the student side, so that indicates a student must take at least one section and maybe take more than one section, multiple sections. So this 1 means the student must take at least one session. And then the values on the section side. So depending on our assumption, so we're seeing that some section may not have a student. So then the minimum number of students will be 0. So that's because this 0 indicates the minimum number of the relationship, this text relationship instance a section can participate. So 0 means does not participate at all. That indicates does not have any student. Because if a section has at least one student, then that section must participate in this text relationship in order to relate to that student. Okay? Then the maximum number of students that a section can have will be the n. Okay, so multiple. So that's kind of using the minimum maximum notation in your design. So once again, I want to emphasize that if you design in your homework and also in your exam, you just pick one of the 2 notations, either coordinate ratios plus participation constraints or minimum maximum notation. Okay, do not use both, because you use both, that just makes your design be redundant, because minimum maximum notation is equivalent to the coordinate ratios plus participation constraints. Okay, any questions? Okay, so let me see. I need to. I think we have assignment. Let me. I do want to discuss assignment a little bit so you know how to design it. Go to the Blackboard to do out the assignment. Okay. Okay, so this is a yard design assignment. So this assignment basically asks you to design a conference review database. So usually in the academic conferences, so people submit paper. So for some conferences, they claim that they have a peer-reviewed papers. So means that the paper will not be guaranteed published unless they kind of get how they're reviewed by the reviewers, and the reviewers basically give the higher rating for the papers and recommend the publication of the or acceptance of the paper. Okay, so this conference review basically follow in this scenario. So in this conference review database, the researchers submit their research papers for consideration. Reviews by reviewers are recorded for use in the paper selection process. Okay, the database system caters primarily to reviewers who report answers to evaluation questions for each paper they review and make recommendations regarding whether to accept or reject the paper. So the data requirements are summarized as this. So as author of papers are uniquely identified by email ID, first, last names are also recorded. So that indicates we need to model author as anti-tab. Each paper is assigned to a unique identifier by the system and is described by a title, abstract, and a name of the electronic file containing the paper. So this also indicates we may need to record paper as an anti-tab. A paper may have multiple authors, but one of the authors is designated as the contact author. So this kind of basically we do have author anti-tab, we do have the paper anti-tab. So a paper may have multiple authors. So I think this is really showing that we may have a relationship between the paper and the authors, right? So paper has authors, okay? Then one of the authors is designated as the contact author. So if you think about we have author anti-tab, we have the paper anti-tab, then there's a relationship between the author and the paper, very kind of a very naive relationship type, means that paper has authors, for example. Then we also need to record the contact authors. So these contact authors can be either an attribute of the paper. If you put contact author as attribute of the paper, then when you refine your design, this contact author has the same anti-tab as author. So that really indicates we may have another relationship type between the author and the paper. One capture authors of the paper, the other ones capture the contact authors. Okay. Then reviewers paper uniquely. So this indicates we need to report reviewer or model reviewers as anti-tab. Each paper is assigned between 2 to 4 reviewers. So we have reviewers anti-tab, we have papers anti-tab. So this statement really showing that we may need to model this sentence may need to be modeled as a relationship between the reviewers and the papers. Okay, a reviewer rates each paper assigned to him or her on a scale of 1 to 10 in 4 categories. Okay, technical merit, readability, originality, and relevance to the conferences. Finally, each review provides overall recommendation regarding each paper. So if we model a relationship between the paper and the reviewers, okay, means reviewers review the paper, then always remember that relationship can also carry attributes. I think those kind of rates or rating on the 4 categories and some other overall recommendation can be actually modeled as attributes of the relationship type, because those are not, if you put those attributes at the paper, then you have some kind of difficulty to model that a paper have multiple reviewers. Each one of them gave their own ratings and recommendations. So it's so hard to capture that part. But if you model those ratings and recommendation as the attributes of the relationship type, then means that our relationship instance will have carry those attributes. So if a paper is reviewed, for example, by 4 reviewers, then that paper will have 4 relationship instances, and each instance will carry their own attributes. Okay, I think that's pretty much I wanted to kind of give you a hint at how to model this part. Okay, and also each review contains 2 types of written comments, one to be seen by the review committee, another one to be seen feedback to the authors. I think this can be also modeled as attributes for the relationship type between the reviewers and the paper. Okay, so another thing is that when you draw the ER diagram, so you either draw by hand, then you take picture and insert into your submission, or you can use any kind of a drawing tools you like to draw the ER diagrams. So either way should be fine. But if you draw your ER diagram, make sure that you draw clearly and so that it's easy for us to read when we grade the assignment. Okay, questions? Okay, I think we don't have much time left for the SQL programming. So I'm mainly to the next class. So next class we're going to discuss SQL programming, and then next Tuesday we will have a brief review, and then if we have time we can also move on to the SQL programming. So if you have time, I think for if you do not know the SQL programming in the past, you never do the SQL programming, then you probably need to review the class, the slides, SQL review, SQL slides, or you can grab any kind of online tutorials. I think there are a lot of nice videos discuss the SQL programming, so you can preview them. Okay, so if you have time. Okay, any questions? Okay, so if you don't have any questions, I think I want to stop here. So make sure to finish your assignment number 2 by this Thursday, and the next Tuesday we're going to discuss it.